Let's work an example problem that deals with torque, moment of inertia, angular acceleration, pretty much everything that we've talked about so far. A rope wrapped around a 2 kilogram solid disc with a radius 10 centimeters is pulled, causing the disc to accelerate from rest to 24 radians per second in 4 seconds. Determine the tension in the rope. Like always, I like to start with pictures and by listing my known information. So what I'm thinking is I have a disc, has a radius, there's a rope wrapped around it, and that rope is pulled. That causes this disc to spin in the direction of the torque with an angular acceleration. So I know that this thing has a mass of 2 kilograms. I know that it's got a radius of 0.1 meters. I know that its initial angular velocity is 0. I know its final angular velocity is 24 radians per second. I know that the time that took is 4 seconds, and I want to know the tension in the rope. So I want to know Ft. Alright, so this is Ft right here. This is the distance r right here. How can I do this? Ft is what? Well, Ft is causing a torque. So I know that the force of tension in the rope is acting with the lever arm R to cause a torque. I know the radius, so if I can find the torque, I can solve this problem. I know one more relationship for torque. I know torque is equal to I alpha. And I actually can get the angular acceleration because I know the change in angular velocity in the time. So I can say alpha is equal to 24 minus 0 over 4, which equals 6 radians per second. So I just got one more piece of known information. Alpha equals 6 radians per second squared. So now if I can get the moment of inertia, I can find the torque. If I can find the torque, then I can find the tension. So now all I need is the moment of inertia. Well, it says it's a solid disc and it's got a mass of 2 kilograms and a radius of 10 centimeters. I know solid discs have the moment of inertia of 1/2 mr squared. So 1/2 of the mass, which is 2, times the radius, which is 0.1 squared. So this is equal to half of 2 is 1 times 0.1 times 0.1 is 0.01, which just gets me 0.01 kilogram meters squared. There's my moment of inertia. So now all I have to do is plug that into my equation up here. So I have torque, tau equals I alpha. So this is equal to 0.01 times 6, and this is then 0.06 Newton meters. Now this is not my answer, this is the torque. I want the tension. So now I have torque equals force times R. So I have 0.06 Newton meters is equal to the tension times 0.1 meters, right? That's the radius. Divide both sides by 0.1, and I get that the tension in the rope is 0.6 newtons. Okay, so pretty straightforward problem. You had to use every relationship. You had to know that torque is force times lever arm. You also had to know that torque is I times alpha. You had to know that alpha is change in velocity over time. You had to know that the moment of inertia of a disk is 1/2 mr squared. You had to know a whole bunch of things, but once you do that, it's just a dynamics problem. It's just a matter of using the equations you know to solve for what you don't.